the future of space exploration. Now many of you are very excited about this settlement, etc. I am a little bit older than you, so I have seen a lot of things, and therefore I have produced, I have my own judgment about where this subject is going. And so I will share with you some of these things. The universe is 14 billion years old, and the solar system is 4.6 billion years old. And when the universe was about 9 billion years old, they did not even know that the solar system is produced. Even the sun was born. So when the sun was born, of course there is a hemisphere, there is a sphere of light. When the light propagated and it was telling everybody that I am born. Okay, you see, you have to go to 4.6 billion years. So many people don't even know we exist. Many places, entire in the past 10 billion years, those galaxies, they don't even know that we exist. So now the question comes that our sun is of course burning protons for 4.6 billion years, and it has fuel for another 5 billion years. Is that the time by which we have to do space exploration, or we are much more constant? When you talk about settlements, did you carry your kittens, your dog, or the birds, or the trees? Did you think about them? If you did not think about them, then you are not going to settlement. That is the place where you are not going to survive for a long time, I guarantee you. Because all of us were born or produced for last 4.6 billion years of evolution. The entire Earth is a single system. You cannot isolate a small part and say, let us go to that planet and let us settle there. This is not possible. Our temperature is adjusted to this climate of this planet. So that is one point, that we should not think about the anthropocentric universe, that the universe was created only for people. The universe was created for there to be many civilizations, and particularly on Earth, entire Earth itself, even that small ant, or a bird, or a tree, blue sky, everything together is a single system. Are we thinking of the whole thing, or we are just thinking of escaping the Earth? So that is my biggest problem. So we mess up this place, let us go to another place. That is not the solution, okay? Now as you know that the universe, that the Earth, that people actually, last 6,000 years, we have Homo sapiens and Neanderthals and so on. We started, these people, they are really, we started calling man only last 60,000 years. The bear, the dogs, the cats, they were born much before us, and they have more rights to stay here than ourselves. So if we mess up the Earth, we actually are doing injustice to them. Even if we talk about the trees, the cyanobacteria that the fossil you saw 3.7 billion years ago, they were all here. If they were not there, we would not be here. The evolution of the brain from the early man to one of the modern men, this brain did not evolve very much. In fact, the brain has gone down by a factor the brain size is about 1.2 liters, and the brain has gone down by several percentage, about 20%. It's okay. Now, so even then we think that we can understand the universe. That's very good, because the brain was not developed for that. Brain was developed to run away from the tigers and to hide inside the caves, etc. And slowly we know the theory of everything. We understand the universe, and maybe we know a lot, but there are things we will be missing also, and that is one of the reasons we may be missing of the art itself. One of the things that positive thing that happened is that we now know that the universe had a hot beginning. It is not a steady state theory. It could be oscillating. It could be a big bang and then big branch and big bang and big branch. So it could be oscillating. That will solve a lot of problems, that what was there before big bang, etc. These are the uneasy questions we don't want to answer sometimes. But the oscillating universe will be there. Okay? And we understood that the James Webb telescope has already seen this part of the universe, long back of our universe, and today we are here, about 13.7 billion years after the universe has started. So From there, we are now sitting in a small planet, the generic planet, around the generic star. So this star is a G-type star, and there are virtually infinite number of them in the universe. In our own galaxy, there are 10 to the power 11 stars almost, and many of them are G-type, of course, and there are planets around them, not only G-type, but around infinite nuclear form planets, and there are exoplanets, and there will be lives, and according to calculations, there will be at least 1 crore planets. There will be more civilized life than us in our own galaxy. Now, the entire solar system has actually started from a small ultra star. Okay, this looks very similar to this. A single ultra star, it lost matter, and then it ultimately matter started making a protogalactic disk, and then this started producing protogalactic disk, and then you have planets around them in the disk, and then you can see that in the large number of planets there is a region where Earth and the Mars has the temperature. They have the temperature about 300 degree Kelvin. This roughly speaking, the 300 to 350 or even 270 degree Kelvin, so that the water can survive there as a liquid, as a solid, as well as vapor. Okay, this is called a habitable zone or Goldilocks zone. So this, and along with many other factors, are the reasons why we have life on Earth. Okay. Now, biggest hurdle, of course, as you know, that if you want to get out of the Earth, we have to have the escape velocity of 11 kilometers per second. And if we want to get out of the solar system, our escape velocity will be around 5 kilometers per second. So, due to the time, we have been trying from this day of Sputnik and this day of Ingenuity and the Perseverance. These are the, basically, we came from there to here, and we have discovered a lot. We have learned about that there were rivers on the Mars, and for some reason the water disappeared. We have recently discovered the water under the Mars surface also. There was some reason why the Mars lost its water. Magnetic field went out, so solar wind actually removed most of the water and the atmosphere also from the Mars. But anyway, we learned a lot. Now how the Venus, rings around the Saturn, lot of things. We have learned a lot, and we thank NASA for that. Most of the knowledge of the universe has come from NASA's explorations. We have also seen large number of exoplanets, 5,000 of them almost places where there are planets we have seen other than the Earth. Those are discovered, many of them have atmospheres like Earth. Okay? There is no signature of life here, but there is no reason why they should not exist. Because the entire universe is not created for us only. We are just a random, generated by random events. Number of events are very large, but this laboratory is also very large, and it is working for 14 billion years. So even if you type randomly, even a monkey, when it types randomly, it will write a Shakespeare's poem if it types long enough. Okay. So if it is a random event, collection of random events, and infinite number of them in a large laboratory for a long time, you will end up producing something which is meaningful. And in fact, the collection that we are sitting in this room itself is an accident out of the entire big universe that we are sitting over together. Now, what is our exploration so far? Look at the Voyager. Voyager, when I was in the mission, a PhD student, that when it was launched there, we were very excited. Ultimately, we went to Caltech, Chicago, and it was going from one planet to the another. Press conferences, and I was moved to it. In fact, I wrote a paper also. What is the thickness of the Saturn's ring? When I was at Caltech, it turned out to be 5 or 6 meters. Many of you do not know, but inside it, you know that the thickness of the Saturn's ring. I used the Voyager data to find out the thickness of the Saturn's ring. Only about the thickness of this auditorium. Okay? About the height of this auditorium. That's it. So now the question comes, it took 44 years, almost 45 years to cross the solar system. Okay? And what is the average velocity? Average velocity is, of course, a little bit higher than the escape velocity from the Earth, because every time it passes to Saturn or Jupiter or something, it swings past and it increases the velocity like this. It is like a slingshot, and then it started going out to outer solar system. So it took about 45 years to go there. Okay, 100 astronomical units. Now, naturally, you need to know, can you go to the Alpha Centauri? Alpha Centauri, if you see the solar neighborhood, so this is our galaxy, let us say. We cannot take a picture like this, but we have taken a picture of another galaxy. So we cannot take our own picture, we are sitting inside. We are from the center 27,000 light years away, and the sun has very much isolated. Sun is not crowded, that's the solar neighborhood. Okay? If you see the number of stars around the sun, there are only 71 stars within 15 light years. Why I have plotted 15 light years? Because if you are doing PhD, let us say at 27 years old, you can go to the this star and come back. It will take 30 years for you. So that's a good thing. Within your lifetime, you will go there and come back, provided you move in a your life. But so we have chosen a sphere about 15 light. Okay. This is the nearest star, Alpha Centauri, Proxima Centauri, as you can see. Light takes about 4.3 or 4.2 light years. So light takes about 4.2 years. Go there and come back. Okay. So if with the present technology, with the wire light technology, or it will be little bit better, like nuclear technology, which can go 30 km per second. It will still take about 40,000 years to go there and then another 40,000 years to come back. And so let us talk about, so we do not, unless you have a time travel or some wormhole or something, like Interstellar movie you must have seen by my mentor, Kim Thorne was a mentor of that movie also, under whom I worked at Caltech. Unless we have such thing, we don't worry about going to the nearest star. It will never happen. Never means, unless you have a time travel. Okay, you can do time travel.